Okay, so chapter P, section 5, part D, which is the last one in this chapter, is called Rational Expressions with Complex Fractions. So simplifying complex fractions, okay, you have two options. First of all, a complex fraction is a fraction within a fraction. That's what complex means, okay? You have two options. One option is to find the least common denominator of each individual fraction, the numerator and the top, or multiply each of the fractions in the entire fraction by that least common denominator, and then simplify. The second option is to find the least common denominator of the numerator and the denominator separately. So you would simplify the numerator, you would simplify the denominator, and then at the end, stay change flip or keep change flip and simplify from there. So there's two processes that you can do. I'm going to teach you both. I'll go through a couple examples doing both, and then you've got to kind of decide what makes the most sense for you. All right, so let's look at number one. Okay, I've got 1 over x over 1 over x squared, okay? So this simply could just be change the division, because this really is written as 1. This is how that's written if I separate it out, right? I could flip it. I could simplify it where the x cancels with this one, and I get just x over 1 or x. Like I said, we're going to baby step our way into the harder ones, okay? That's one option. The other option is look at all the denominators in my fractions. So you're going to have a denominator in the top and a denominator in the bottom. Find the least common denominator of those. It would be x squared, okay? Because it's a single term raised to the highest exponent. Then multiply all of this by x squared, which means I'm going to multiply the top by x squared over 1, the bottom by x squared over 1. This goes into this x. These cancel completely, and I end up with x over 1, which is still x. If it's a single fraction in the top and the bottom, I would highly recommend sticking with the first method, which is just say change flip, okay? It's going to be a lot easier. As we get into more complicated denominators, it may be easier to do the second option. But this is, again, completely up to you. You have to figure out what works best for you. All right, 1 over x minus 2 over 1 over x squared minus 4. So this is 1 over x minus 2 divided by 1 over x squared minus 4. Keep, change, flip it. And now we're back to where we were in the last section, 2 sections ago actually, where we would factor all 4 spots if we can. The 1 can't get factored, the x minus 2 can't get factored. The top right is x plus 2x minus 2. This is now gone. And then cancel top to bottom left or cross, right? So I can do x minus 2 and x minus 2 here. Now my numerator is just 1 times x plus 2. The denominator is just 1, so this would be just x plus 2.
Mommy,
yes.
Look.
Questions on that method, which again is the one I would highly recommend if there's only one fraction in the top and the bottom. Now let's say I go the other route. The other route is find the least common denominator of this denominator and this denominator. So I get x minus 2 and x squared minus 4, which becomes x plus 2x minus 2. My least common denominator would be x minus 2 and x plus 2. So I'm going to multiply the terms in the top by that, x minus 2, x plus 2 over 1, and the bottom, x minus 2, x plus 2. The x minus 2's cancel from here. The bottom, this factors, remember this is x plus 2x minus 2, would cancel completely. So in the numerator, this whole thing here, I have x plus 2 over 1, which is just x plus 2. The denominator, this whole thing here, I just have a 1. And my answer is just x plus 2. So I'm going to say it one more time. But again, if there's just a single fraction in the top and the bottom, I would highly recommend the first method. Just do your keep, change, flip. Questions on those? All right. You try number 3. Okay, so you should make this 1 over x plus 3, x minus 3, divided by 1 over x minus 3 becomes 1 over x plus 3, x minus 3, oops, times x minus 3 over 1. Cancel through the x minus 3's, and I get 1 over x plus 3. Everybody good on that one? Yep. Okay, now 4 gets a little bit more complicated. So I've got I have 2 terms in the top, 2 terms in the bottom. So I'm going to work through the 2 options, and again, you decide what works best for you. One option is to figure out, simplify the numerator, simplify the denominator, and then do keep, change, flip at the end. So the first one, would be 2 over x minus 3 over 1. I have to give them the same denominator. So 3 over 1 becomes what over x? I'd have to multiply by x and x here. And I end up with 2 minus 3x all over x. That's the numerator. Then I have to simplify the denominator. So I get 1 minus 1 over x minus 1. I'd have to change 1 over 1 to be something over x minus 1, which means I have to multiply by x minus 1, and I get x minus 1. So this is x minus 1 over x minus 1 minus 1 over x minus 1. That becomes x minus 1 over x minus 1, or x minus 2 over x minus 1. Yep, no worries. Okay, so I'm going to go all the way back. I've got 1 minus 1 over x minus 1. I have to give them the same denominator, right? So this over 1 has to be x minus 1, which means I'd have to multiply this times x minus 1 and the numerator, which is 1, times x minus 1. So I get x minus 1 over x minus 1, that's what 1 is, minus 1 over x minus 1. Now both the denominators are the same, so I can combine my numerators, x minus 1 minus the 1 over x minus 1, which becomes x minus 2 over x minus 1. And that's the denominator. You good so far? Now I'm not done yet. I still can't leave a fraction within a fraction, which means at the end here, I have to do stay, change, flip. 2 minus 3x over x divided by that means when I bring it up, I have to flip it. X minus 1 over x minus 2. Still good? Now, I want to look at these and I want to say, can I factor and simplify? None of this factors. If I could factor, I would. If I can cancel top to bottom or diagonally, I would, but I cannot, which means my answer is going to be multiplied straight across 2 minus 3x parentheses x minus 1 over x times x minus 2. And you want to leave it like that. Questions on that one? I went way off that slide. Well, let me go back and do it the other way. Okay, so I'm going to rewrite it. Okay, second method is find the least common denominator of all the denominators. So there's only two denominators here, x and x minus 1. The least common denominator of those would be the product of that, x minus 1. So I'm going to multiply that times this. I'm going to multiply that times this. I'm going to multiply that times this. And I'm going to multiply, what color did I not use? That times this. From this, the x in the bottom and the x here cancel. And I would just get 2 times x minus 1. Which becomes 2x minus 2. This negative 3, there's nothing to cancel, so the negative 3x gets multiplied by each of these. So negative 3 times x minus 1 becomes negative 3x squared plus 3x. This, nothing gets canceled, so it's x times x minus 1, which becomes x squared minus x. And this, the x minus 1's cancel, and I'd have negative 1 times x, which is negative x. Now I'm going to simplify this fraction by combining my like terms. Negative 3x squared plus 5x minus 2 all over x squared minus 2x. And all of that can get factored. So in my numerator, I could do first times last. Negative 3 times negative 2 is positive 6. Factors of positive 6 that sum to positive 5 are 2 and 3. I'd get negative 3x squared plus 2x plus 3x minus 2. Factor by grouping it. I get x here, actually negative x, 3x minus 2. Plus 1, 3x minus 2, and I get 3x minus 2, negative x plus 1. In the denominator, I can take out an x, and I get x minus 2. It's the same answer. So the signs are different on the x minus 1 and the 3x minus 2. Ooh, I almost tripped. But the answer is the same, okay? It's just the signs are different. Completely different processes. You have to figure out what's going to work best for you. My advice is if they're like easy denominators, if it's like an x and an x squared, then maybe multiply all of it. But you see that second process is a lot more involved when it doesn't need to be all the time, okay? It tends to be simpler to just simplify, and separate. Keep, change, flip at the end. But again, you have that option. You do have two options here. You can always multiply by the greatest common factor, or the least common denominator of all the denominators at once, or split them numerator and denominator and then simplify. Questions on the process, because that's really all it is. It's just we're going to get more complicated kinds of questions. Everybody's okay? Yes? Okay. Okay, next set. Oh wait, let's go to number 5. Okay, so we're going to look at the first way. In that one, x plus 5 is already done. There's not a fraction in there. But in the bottom, I get x squared over 5 minus 5 over 1. So I have to change 5 over 1 to have something over 5, which means this is 25 fifths. And I get x squared minus 25 over 5. That's the denominator. Then I'm going to keep, change, flip. Keep the x plus 1. Change this to multiplication. Flip the 5 over x squared minus 25. Can I factor that?
Yes.
Yes. What gets factored?
The denominator is the difference in squares.
Good. Difference of 2 squares. That becomes x plus 5, x minus 5. This is over 1. Cancel across. The x plus 5 cancel, and I get 5 over x minus 5. There's my answer.
I'm confused as to where you got the 25.
So I have to change this to be over 5, right? 5 over 1 becomes what over 5? I had to multiply by 5, and I get 25 fifths. Does that make sense?
Yeah.
Okay. All right, now let's go through second process. Second method. There's only one denominator this time within the fractions, and it's 5. So I can take and multiply everything times 5. The 5 would get distributed here. I'd get 5x plus 25 in my numerator. The 5 can get multiplied by both of these fractions. From the one on the left, it's going to cancel, and I get x squared. From the one on the right, I'd get minus 25. This would be 5 times x plus 5 over x plus 5, x minus 5. And the x plus 5s cancel out. And I get 5 over x minus 5. Same answer, different process. You pick. We still okay? Aren't complex fractions fun? It's like you took factoring and then combined it with least common denominator and fractions. Yay. All right, so this one, you can kind of ignore those parentheses in the bottom. They're just showing you that that is its own fraction. Okay, so it is x squared minus 1 over x squared minus 1 squared, or x minus 1 squared over x. So my advice, there's one fraction in the top and the bottom. Go with method 1. Keep, change, flip, or stay, change, flip. Top left factors to x plus 1, x minus 1. Bottom right is actually x minus 1 times x minus 1. Cancel, top, bottom, diagonally, which means my x's cancel. And my x minus 1 cancels with one of the x minus 1s. And I end up with x plus 1 over x minus 1. That cannot reduce. Those are not opposites. Okay, so my answer stays that way. If I had done it the second method, I would have multiplied everything by x because that's the only denominator. X in the top and x in the bottom. The x's cancel. I would have gotten x squared minus 1 over the x's cancel. I would have gotten x minus 1 squared. X plus 1, x minus 1 over x minus 1, x minus 1. And these cancel, and I'm left with the same answer. So again, both methods work. You just got to pick whatever you prefer. Okay, you try 7. All right, so obviously and you could do either way, but this time there's only that one x. It might be easier to do the second method, which is multiply everything times x. So this 6 over 1 times x would be 6x. Minus the x's cancel, and it's just 5, over 1 times x is x. X's cancel, and it's plus 5. This can't be simplified, so this is my answer. That's method 2. Method 1, I would have to change this to be over x. So I'd end up with 6x over x minus 5 over x over, change this to be over x, and I get x over x plus 5 over x. Combine my numerator, and I get 6x minus 5 over x plus 5 over x. Keep, change, flip, and I end up with the same answer. So that time it was actually faster to go with with method 2, okay? When it's just like a single term on the bottom, I would say that's probably when it's easiest to do that. But you should get the same answer either way. Raise your hand if you got the right answer. Yep, good. Okay, all right. Okay, 8 gets again a little bit more complicated. So you can either multiply everything by the least common denominator, which is going to be a times a plus 1, or you could separate them out. Either way, denominators are both going to be the same. A times a minus 1 in the top, a times a minus 1 in the bottom. So if I need to change each of these, this I'm going to have to multiply by a, and I get a squared, so that's the first one. This I have to multiply by a plus 1. 1 times a plus 1 is a plus 1. This I also have to give the same denominator. I have to multiply by a plus 1. And last one over here, same denominator. I have to multiply by a. Now the numerator has the same denominator, so I can combine that into 1. A squared plus a plus 1 all over a times a plus 1. Over, denominator has the same denominator. I can add those a plus 1 plus a over, God bless you, a times a plus 1. And this becomes 2a plus 1. Now keep, change, flip that. So a squared plus a plus 1 over a times a plus 1 times, flip this, a times a plus 1 over 2a plus 1. The a and the a plus 1 cancel. There's no way to factor this. There's no factors of 1 that sum to 1. So my answer stays as a squared plus a plus 1 over 2a plus 1.
Wait, what did you cross out in the green? To do a plus 1.
It was a plus 1 plus a, so I just made it 2a.
Okay.
How we doing? Still okay? I'm hoping that the black squares are not sleeping, because obviously this stuff takes practice.
So this is just like the division of the last lesson.
It's like combining, yes. It's taking, adding and subtracting, and then combining it with dividing.
Oh, okay. Thank you.
You're welcome. All right, last slide. So look at 9. How many denominators are in 9? 1, right? There's 2 fractions, but it's the same denominator. So my least common denominator is just going to be x. This is a case in when it's probably easier to multiply everything by x. So I would do each term by x. I get 2x. These cancel, minus 2 over 2x. These cancel, plus 2.
Sorry if there's any background noise when I'm answering because I'm at my mom's school.
Now I can take out a 2 from both the top and the bottom. My 2's simplify, and I get x minus 1 over x plus 2.
Wait, why did you do x plus 2?
Because I wrote it wrong. I was just making sure you're paying attention. Nicely done. It's x plus 1. Still with me? Ready for the last one? All right, 10. 1 over x plus 3 minus 1 over x over 1 over x. Now you've got different denominators, so it might be easier to do it the first method. Again, you can choose. but let's do just the numerator first. My least common denominator here would be x times x plus 3. So I'd have to multiply this one by x. X times x is x squared. No, sorry, I'd have to multiply that by x, so I'd have to multiply the top by x. 1 times x is x. Bottom, I'd have to multiply this to get to here by x plus 3. And that becomes x plus 3. Now there's a minus in between these, so be careful. That means x over x plus 3 minus x plus 3 over x times x plus 3. That minus is going to carry to both terms. So I get x minus 3 over x times x plus 3. The x and the minus x cancel out, and I end up with negative 3 over x times x plus 3. That's the numerator. The denominator, lucky us, we don't have to do any work. It's just 1 over x. Now we're going to keep the top, change to multiplication, and flip the bottom. Cancel out the x's, and I get negative 3 over x plus 3. Questions? If I had gone the second route, 1 over x plus 3 minus, 1 over x over 1 over x, I would have had to multiply everything times x plus 3, because that's the least common denominator of all of it. Here the x plus 3's cancel, and in the numerator it's just x. Here the x's cancel, so it's minus x plus 3. And here the x's cancel, so it's x plus 3. I still end up with x minus 3 over x plus 3, or negative 3 over x plus 3. So both processes work every time. Sometimes they're easier than others.
Wait, in the first method that you did it, how did you end up with the denominator of x plus 3 and not x?
So this was after we pulled this over here, right? That's my denominator. This came after I simplified the numerator, and then 1 over x was the denominator. I didn't have to simplify anything like that. And then I do keep, change, flip. So I keep this the same, which becomes this. Change it to, what? Oh, you're recording. Change it to multiplication and flip the bottom, which becomes x over 1. Then you can cancel out the x's across. And you're good? Yeah, okay. All right, any other questions on this? I know it's called complex for a reason. Okay, it is complex, but it's basically just combining the skills you already have. The good thing about it is that it's going to force you to practice factoring, because you're going to get that again. It's going to force you to practice division, because you're going to get that again. And it's going to force you to practice addition and subtraction, because you're going to get that again. So it's actually doing, like, you're reviewing a lot of skills within here. The homework tonight is not on WebAssign. This was the really complicated questions. They were hard to answer. So it is a PDF. Okay, let me publish it so you can see it. It should now be on your to-do list, okay? The answers are there on page 2. Just make sure that you show the work. Don't think for 1 second that you will get credit for this homework without showing work, okay? There's a lot of work that goes into these, so make sure you're showing all your work, but also use the fact that you have the answers there to check them as you go.